Okay, now.
Now we're live. Okay, okay. I'll recap that story then. So I checked out the website for what you guys did, and it really, really touched me on a very personal level because none of you know that I actually wear hearing aids myself. I wear two. I've had this all my life, and so reading the story about the boy who said he goes to school now and people ask him about his robot arm instead of asking him why are you different, that totally touched me because I got that question when I was a kid. Why are you different? I had these big boxy hearing aids, that I wore, and so my daughter also wears hearing aids, and so I'm determined to make sure that she grows up with a lot more comfort with these devices and not the stigma. So I think it's completely awesome what you guys are doing, and as a company, once we get our production units running successfully, we want to donate one to the e-NABLE cause to help you guys out on this project. So,
Very cool. Thank you.
so, so I wanted to start with that, and then I'm definitely happy to open up the conversation to questions and try to give you guys a better understanding of our product and anything else you guys might want to talk about.
Great. Yeah, I think that's really wonderful. I mean, as you may remember, I backed the project, big fan, love the idea of exploring the range of materials, and really looking forward in particular to seeing what the possibilities are related to prosthetics with printing with things outside of I guess traditional feels like a funny word for 3D printing, but the traditional materials. Yeah. And I'm sure plenty of the others on the phone, on the Hangout, can elaborate on that. Like Trouble, I know you've been looking at this area for a while.
Yeah, yeah, I've been very interested in the paste extruder just because the different types of materials that it can be used for.
Mm-hmm.
Even just being able to print with silicone and such, but I'm also intrigued by the possibility of using just paste as support material in a dual extruder type arrangement, so that we don't have to build the little supports out of like the little pyramid supports and things like that. So a material that hardens a little bit but is easy to break away when you're done. I could see that being of use. I can see I don't know. I can see a lot of possibilities with this, and a lot of them just seem like things that are going to come from other people that I don't have. Yeah, sorry about the delay. I've just been putting the notes together, so I think I just posted it in the sidebar.
Yep.
I've set it up so that anyone who has that link can edit the notes, and let's see.
All right,
Yep.
and what I might do is I may review the notes after the conversation, and then I can provide like some extra edits, or obviously I won't.
I also tend to get the links that are in the sidebar and copy and paste them into the notes when we're done. So if you want to post links in the sidebar, we'll get those into the notes too.
Okay, excellent, excellent. So, but I can review the notes later as well, just in case there's a question or something that doesn't quite answer it as much as we might like. I can go back and review it later and provide more detail or clarification or something. So, so yeah, Trouble, you're right about the support material idea. One idea that we tossed around, we haven't tried it yet, is that using something like cake icing as a support material, because that washes away with water, basically. And well, it seems intriguing to us. It seems very possible, very realistic, but we actually haven't tried it. So, and that's kind of what we had to play the cat and mouse game here a little bit with the timing of our product, because makers themselves are a very creative group of people, and we're makers, but we don't know everything. So we basically decided to go ahead and take the plunge, release our product, and then somebody is going to have an idea and they just want to try to pursue it, and they'll be able to use our product and test some. Basically extend our research lab far more than what we're able to, and far quicker.
Yeah, that's how things generally go with open source technologies like this. So, have you tested the extrusion width of your syringe extruders much?
A little bit. What we tried to find were optimum widths. Generally, we see people like to go smaller and smaller and smaller, and I encountered that same problem with my PhD project. My supervisors were interested in, oh, okay, you're printing 100 microns, so what? Can we print, 10 microns or 5 microns or whatever? But when it comes to extrusion printing at that scale, very few people have succeeded. One researcher who has, and has been doing it for 30 years, is Jennifer Lewis, who used to be at the University of Illinois. Now she's at Harvard. And I followed her work for a little while. So she's been able to do 5-micron silver wires with a very specialized system. It's not something you're necessarily going to do on a desktop system, without a lot of effort. So we have tried to focus more on what are the day-to-day widths that you can print with. So the tips are they're a basic tip selection from a company called EFD, and which is engineered fluid deposition or something like that is what that acronym stands for. They have a Luer lock on them so they can withstand the pressure of the fluid being compressed through. And the tips range in size, what EFD can provide, from 50 micrometers internal diameter all the way up to 1.5 millimeters. And so there's usually about 100 micrometer, 50 micrometer steps in between that range for the various sizes. For something like silicone, we found that the cone-shaped tips tend to work the best for that material, and we've been able to print that out of about a 400 micrometer nozzle. And when the material is compressed from the Z point of view, it spreads a little bit, and but when you look at the layers, they're nice and compact, very well filled in. So if you get your print setting right and your steps right and everything like that, that's generally what we printed with very reliably with silicone.
So it's ballpark about where the usual filament printers are working. I mean, 0.4 millimeter nozzle, you probably end up with like 0.5-ish extrusion width, and you do like what,
exactly.
3 layers?
Yep, exactly. And certainly there's going to be ways to push the system and get finer resolution, or maybe there might be some, here's an idea that you can use for everybody does post-processing with plastic, and that's also a possibility with silicone, because silicone in its liquid form is an adhesive. So if you printed a bulk silicone shape just to get some form using a big fat nozzle, then you could use something like an ice cream stick with regular silicone in a bowl and just smear it around the outside as a post-process to get a smooth finish, or something like that. Those are also possibilities. So there's a lot of interesting ways to look at how you use silicone with our device for 3D printing. And you can also make, jumping in with other ideas, you can actually, if you have 2 pieces of silicone, for example, and they're not really, or if you have 1 piece of silicone and because of the shape of the design, it's not, it's going to fail, say, on the second half or something like that. It's also possible then to break your design into 2 pieces, a bottom half and a top half, print them separately, and then glue them together with liquid silicone at the end as well. So, more ways to think about it.
Yep. 2 more questions. What sort of silicone are you using actually? Is it a 1-part stuff that'll cure in your disposable nozzles after a while, or 2-part thing with little mixing nozzles?
Right, exactly.
What durometers have you got?
All right, sure. We're using a single part, 1-part right now, stuff that's straight from the hardware store. It's got acetic acid residue that dries. It's a reaction with the moisture in the air to cure this. It cures in about 24 hours, but upon printing, it holds its shape very well, assuming that the shape is somewhat optimized, at least for a paste type of material. And it is possible to work with the 2-part silicones, but we haven't really explored that in depth because usually you have to get your mixing just right. It has to either be a full 50-50 ratio or a, 60-40, kind of by weights or something like that. And then you have work time to contend with as well. So you may find that it's a 30-minute work time and your print job is going to be 45 minutes. So then, the stuff's going to be changing while your print's going on, and the last bit of your print may not turn out. So we haven't had a chance to really look into that in depth. We've had people ask us about medical-grade silicone, for example, and then there's food-grade silicone, and so it's just some areas we haven't had a chance to explore yet. But for all our samples right now, we've been using just stuff straight out of the hardware store with the idea of, hey, this is $5 versus $50 a kilogram for filament, and it's still 100% silicone. But it's just not like something like the medical grade or a special type of two-part. What was your third question?
Where was I? Oh, are you seeing like pretty man, what is the term? Pretty homogeneous silicone material, or are you getting sort of the usual cross-hatching patterns that extrusion printing tends to have? So are there voids in your silicone parts from the nature of extrusion printing?
All right. Well, so we're using our system is mechanically driven, so it's not driven by air pressure. So that does help alleviate the issue of voids. Depending, the voids, from what we found, depends a lot on the shape of what you're trying to print. We actually printed a bracelet. There's a bracelet that has that's on Thingiverse, that has these really nice facets kind of on the sides and angles and stuff like that, and kind of funky looking. And we had somebody playing with it, just sort of stretching the silicone to see, okay, when's it going to break? And it broke. And so we got to see a nice side profile of the inside. And so it did have some pores. It looked a little bit spongy, but they were actually extremely small and extremely uniform. So depending on your application, it may or may not be an issue. But that is one thing that we saw, and we haven't studied it further to see if there's a way we can eliminate that by setting the print to go a certain way or what. So
yeah, I just put up your website. It looks like it does have some pattern to it, but it's not exactly significant. That's pretty nice.
I have a.
Have you?
Question.
Oh, go ahead.
Oh, sorry. I've noticed that you have a lot of your pictures on your site have more than one syringe inside the box at a time. Does that mean that you can print with more than one material going through the same tip at the same time, like for epoxies that harden after they mix?
Right. Yeah, I don't. You might have to help clarify for me which pictures those are, because we've never had multiple syringes in the actual unit itself. It's a single syringe system right now, and again, this is basically just to get it out to the makers as quickly as possible, rather than try to also develop a dual one. That's not to say that we don't have our minds set on a dual one in the future. So, however, you can use two of the singles side by side on a 3D printer and basically have two materials coming through that way, and coming through either two separate nozzles, or you can use easily sourced connectors to join the two tubes, flow the material through a mixer that will evenly mix those two materials and then print out of that. There would be ways to do that with our device, and take a little bit of some hardware hacking, nothing too fancy, but just it might be a little bit of effort.
Yeah. I like the idea of printing with epoxies, but I do realize that a lot of them aren't very solid for several minutes after they are mixed, so it's not a great idea, but it was just something that was bouncing around that I thought was worth asking. I'm guessing that your multiple syringe pictures are just showing that multiple different materials can be in the syringes, and you're just showing them side by side on.
Yes, yeah, exactly. Because the way the system is designed, everything is the materials never come in contact with the mechanics. So you can print silicone, and you know it's in the syringe and the connectors in the tube all the way down to the tip. It's all isolated from the mechanics, and so within 5 minutes of printing silicone, you can put cake icing in our system. You take out the silicone parts and you put your cake icing parts in there. Change the substrate, you know, so we use wax paper for silicone and we use aluminum foil for cake icing, so you change that out and then there's no contamination.
Right.
So yeah, it's really easy to go between materials on that. So that was the idea of that illustration.
Okay, that makes sense. I'll let Nick take over again since I interrupted him.
Yeah, have you considered putting a syringe extruder on the same gantry as a normal filament extruder and using, like, say, a really non-viscous polyurethane to fill in the interior of parts?
Yeah, I mean, by putting the mechanics on the same gantry as the existing filament extruder, that's what a lot of other designs have done. And part of the reason we didn't do that is because there ends up being a lot more design and customization that you have to do for each type of printer you want to work with. Whereas the way ours is designed, all you've got is this tip at the end of a tube, and so you know, somebody can put it on their printer with a zip tie if they want to, and then in addition, our design, it expands the range of printers it can work with. So if you think of this whole mechanical system on a gantry, that's not going to work on something like a printer bot. The printer bot itself is probably going to topple over. It'll have a weight maximum on what it can work with.
Oh yeah, no, I love that you've taken all of your mechanics off of the gantry. I meant using a syringe and a normal extruder at the same time. So you would print a shell out of PLA and then dump a bunch of polyurethane inside of it to strengthen it without wasting time.
Yes. Okay, I got it. Okay, so using our device to just do a dump of some glue or something like that, is that?
Yeah, some filler of some sort. Yeah.
Yeah. So that's possible. The trick is going to be how you do the G-code in that. So because you want the printer to do this automatically, right? So you would want the G-code to basically go to some position and then just extrude for some amount of time until your reservoir is full, and then move out of position and go back to the filament nozzle. Off the top of my head, I don't know exactly how that would be done in G-code, but people who are more familiar with G-code may have some ideas on that.
Yeah, I'm wondering, could you, because there are software that you can have two extruders with different sized filaments, etc. So theoretically, you could treat, say, a PLA extruder as a fine filament extruder, and then treat a silicon nozzle as a really fat extruder, and configure the software to slice the infill that way. And I'm thinking that might work. Other than good luck measuring all the offsets, but if you've got some calipers, I think it ought to work.
Yeah.
Because that's essentially what you can do with most of the multiple extruder printers that are out there.
So that feeds into my next question of what kind of integration to the firmware do you have to do for this? Is it a little PWM to tell you position along the syringe, or?
Okay, so you mean to integrate this syringe with an existing printer? The tip?
Yeah, into Mardlin or whatever firmware flavor you're running.
So to connect our extruder to an existing printer, physically, you just have to know the distance between the end of the plastic tip relative to the end of the filament tip, and then you just put those settings in your system as if you were just adding another filament extruder. You still have to know the linear distance between the two extruders. So that operation stays the same. The change to the firmware that we typically recommend is the disabling of the heat failsafe, because in the Mardlin firmware, and this is part of because extrusion printing of paste is not really widespread, so everybody's adopted stuff for just melting plastic, right? So a heat failsafe certainly makes sense for that. But when you're printing paste, you want to disable that, otherwise it'll never get ready to print. It'll just be waiting, waiting, waiting. And so you can update the firmware to disable that failsafe. It's just commenting out that variable. The other way to do it, if you don't want to update the firmware, is you can supply G-code to basically disable it during your print session, I think. And then if you reboot your computer and your printer, then that goes away and you're back to the original settings again. So
yeah, you can just put an M999 into the start G-code and it'll turn that off. No, I was asking how you control it, but it sounds like you've just got a stepper controlling this?
Yes, yeah, actually, yes, that's right. That is correct. Because we wanted to be able to integrate very seamlessly with existing printer systems. And that's what all the filament extruders are using as a stepper, so it made sense for us to use a stepper.
So what printers have you worked with so far? I mean, I saw
What's
the
that again, sorry?
Yeah, I was curious which printers have you integrated with so far. I saw the Mardlin article that you posted.
Yep. So right now our workhorse is a Felix 3.0 printer, and my co-founder Andrew is he's very familiar with the he built his own rep wrap, so he's very familiar with that. That's how he learned 3D printing, and he has a Replicator 2X at his university research lab, and so he's been the contact person, for all the other researchers, and supporting that printer and teaching all the other students. So he knows that one inside and out. We haven't actually tested the integration with that yet, but we're highly confident it will work for that. And we've also signed up to be MakerBot distributors or resellers ourselves here in Canada. So at some point in the near future, we will have a 2X ourselves here that we will be able to start playing around with to verify. But because as we've gone through the integration ourselves on this Felix printer and our familiarity with the typical ramps architecture and everything like that, we feel it should be pretty standard for most printers out there. The printers that we tend to discourage are things like the Micro 3D printer, that one that had 3.4 million on Kickstarter recently. Because while our product will work with that, they had to do a lot of optimization for the manufacturing process that made their printer a lot more proprietary. And so yeah, even though it takes G-code and whatever, you have to do some splicing of wires and soldering and things like that. It's not as plug and play as it would be on a ramps type of system. So anyway, we didn't get a test on a lot of printers. We would have loved to have tested on more. We do intend to buy a printer bot, for example, in the near future as well, and start testing on that. So again, it was one of those decisions on, okay, when do we go to market? Do we get more printers first, or so on? But we do believe it's going to work on a wide range.
Are there any printers that people are particularly curious about that we can address directly? Hi, I'm John.
Hi, John.
I wouldn't say so. I mean, we all use pretty popular printers, and all of the designs that we recommend using in e-NABLE are smart enough to use stuff like groove mount and generic, shared standards. So they're not going to do something silly like block you from modifying E-steps or something like that.
Right.
Yeah. Cool.
We did have some manufacturers, we've had a number of manufacturers actually very excited about our product and reach out to us. And so Airwolf 3D is one example. They even posted on their own blog that any of the schools that have the Airwolf printer, that they will support the installation and integration of our product with their printers. So I think the potential is definitely there, and our intention is not to try to compete with these other printer companies. We want to provide this value add, which, that's kind of the way the 3D printing market is, from our observation, is that people have their favorite printer. They don't want to go buy another printer, not unless it's just absolutely drop dead, but most of the time, yeah, they've got their favorite printer, and they want to continue using that. They're very familiar with it. They know all the little quirks, how it works and stuff, and so so our device helps them continue to get more out of the people they already have, and that's kind of been our philosophy.
That's the right way to do it. I'm so sad that the Mark I doesn't sell their freaking carbon fiber extruder as an extruder. They put this whole box around it and sell it for $3,000 a piece, and it's like, oh,
yeah,
look, $2,000 markup on your gantry. I'm not
Right.
buying that.
Right, exactly.
Yeah.
So, because I missed it, and I'm sorry that I had some funny issues there, but have you guys gone into the sort of specific things that you would like to do with soft materials in your printing?
I can jump into that. So we've
Yeah.
been playing with the with flexible joints here at Emory all summer. Emory is a program at Rice where we work full-time on open source projects, so there's two of us here working on e-NABLE development.
Mm-hmm.
And we've been casting parts in printed molds and then sticking them into our actual designs. And I mean, that works, and we can cast most materials. Some of them get stuck in the molds, but whatever. But that kind of limits what shapes we can use in these joints. I mean, it has to be something that we can insert somehow.
Mm-hmm.
So particularly for the CMC joint in the thumb right here, it would be nice to have basically just two balls with a cylinder in between them, but there isn't really any way to stuff that in there. So printing that as I printed the two parts that the balls go in would be a nice trick, which is part of why I was asking about mounting on with an existing filament extruder. And by the way, what's the
silicone?
Yeah, it's we've been using smooth-on two-part products, but the only really important factors out of that is the durometer and the elongation at break.
Mm-hmm.
So we can probably find something extrudable that has the same sort of characteristics.
Right. Now this. There is the idea, obviously, as you mentioned, Nick, of printing this all in one go, but have you thought about if you're able to print the parts separately and then assemble them? Does that still work for your device? In other words, if you print it...
We could print say the hand parts in two parts and then screw them together around this thing, and being able to print soft materials would still help with making that two spheres with a connection in between them would just be a pain if I was molding it, because I have to fill two halves, and it would be a mess. It would be a two-part mold at best, maybe a three-part mold, which would just be unfun to try and seal when they're 3D printed. So at the very least, being able to print those would be nice, but it would be even nicer to not have to screw together anything to use interesting shapes like that. And then there's also the matter of...
right?
Huh?
I said this shape is kind of like a cartoon barbell, is what I'm envisioning.
Yeah, I mean, that's one example, though. It would also be wonderful if we could print fingertips, or padding, essentially, because we can cast them on, but they don't hold very well because they're just a surface coating. So if we were to print them on with rings of pliable material looped in to attach that mass of pliable material more securely, it'd be a neat trick. And you could also customize the texture of it a bit too. If you've seen the little nubbins that we have on the fingertips of the hard plastic parts, those in pliable
plastic doesn't really let you grip really fine things like a bead or something like that very well.
Nah.
So let me throw out some other ideas, because this is an area that we've actually thought about. We've seen images of plastic hands, and when people ask, what else can your device be used for? What else can you print? And that's one of the things we've thrown out, is that it could be the plastic hands. You could 3D print the ligaments that you can snap in place, and some of the string components or something like that. To give it a bit more of a natural feel to it. And so it sounds like our guest is correct on these kinds of ideas. And then the fingertip thing, that's another idea that we've tossed about. And so it's awesome to see that those are some of the ideas that are progressing for this project. Another way to use our device is it can also be used as a standalone without a printer. In other words, you can hold the tip itself in your hand, and you hit extrude for a certain depth or whatever, and then it's extruding very much like one of these filament pen printers. Okay, and so then you can use it in pen form and put your material, say, on a fingertip or as a glue in something and whatever. So that's another way to use our particular product.
Oh, that's very interesting.
Have you fooled around with moving away from silicone, clays, curable or otherwise? Or like ceramics that you could also potentially extrude?
Yeah, we've tried looking at clays, and we haven't found anything out of the box that is optimized and ready to print. We were reading on the Rich Wrap forum about the guy there printed plaster of Paris, I believe, with his extruder, and so we tried that recently, and interestingly enough, it seems to be there's some sort of reaction that happens when you add water to plaster of Paris, that the whole thing really starts to heat up. And we found it, basically curing inside the syringe, and we're like, okay, this isn't going to print. It's rock hard already. I'm banging it on the table, and it's clunking, and it's not, So that failed. And then ordinary pottery clay is a little bit too thick. We would have to cut it with water, and if we get the right consistency, we feel pretty confident it would print. But it wouldn't have the same density as you work with it out of the box. That's the other thing. So clay is still an area that we're exploring to try to, because neither I nor my co-founder Andrew, have done a lot of research work in clay. So it's not an area we're entirely familiar with. It seems like it should be relatively basic to get the right kind of mixture and do some printing with it. And obviously there have been some results on the internet, but we haven't been able to find any secret recipes anywhere. So it's kind of going to be up to us, I think, to figure out the optimizations and go from there. Or hopefully maybe somebody will share some secrets with us.
Yeah. Real quick, you sell.
We have printed Play-Doh, by the way. And add that in there.
Play-Doh. Fun. You sell fillable cartridges that you put whatever you want in, or like pre-filled cartridges?
They're going to be fillable with whatever you want. They'll be empty and they'll be sterile. So if you need those kinds of conditions, it's all there. We do plan to get into pre-filled cartridges in the future, and that's just because with our engineering background, our chemical background, we have some materials in mind that we think would be pretty awesome for 3D printing that nobody's really using right now. And so we'd like to try to bring some of those materials to market, and it certainly makes sense to do it with the syringe pre-filled. From a company management perspective on that, in the background, what has to go on is because when you ship chemicals internationally or even just domestically, you end up opening up a whole new bag of shipping problems because, oh no, now it's a chemical that you're shipping, and is this hazardous, whatever. So
yep. I buy lipos all the time. I understand how unfun shipping rules are.
Yeah, I think that's one thing though, that what Charles is getting at is an interesting opportunity for working with the e-NABLE team, because you're the kind of people that would be probably able to give us some really good feedback on the gaps for what we know there need to be materials we optimize, but we don't necessarily know what kind of properties people are really looking for. So having people who are really pushing the boundaries, working with it, will be exciting for us.
And what's the timeline on this? When are you going to start having deliverable devices?
We're targeting to ship the beta units in September. So we're currently in the process of locking down a professional design firm to work with us on finalizing the unit. We know what it needs to look like. It's just a matter of making the design something that we can manufacture. And then we've got a few manufacturing connections that we're going to be in touch with. So we think it's going to be a tight schedule to try to ship the betas by September, but we're going to be working very hard to try to stick to that if we can. As we learn on this, there might be some minor delays, but we don't expect to be anything like 12 months down the road. People on Kickstarter who backed us still haven't got their product or something like that. We don't expect anything that ridiculous. That's pretty much where everything ends.
Cool. Pretty soon. I don't have a printer that I can hack on right now. I've just got lab printers that are not mine to disassemble. But I'll be building myself a nice lab unit to fool around on when I get to college.
No worries. My co-founder Andrew, his PhD supervisor is actually really excited about our product, and we're actually going to put together a printer for his research group as well. So we may be able, depending what printers your lab actually has, at some point we may be able to provide some guidance on how you can integrate it if the larger research group is interested. In such a way that we can be confident it's not going to cause any problems with that.
Oh, it's not that. It's just the machines are busy. We have other stuff to print.
Oh, okay.
And I'm only here for another 4 weeks anyways.
Okay.
I'll have my own Delta in like 6 weeks. It'll be fine.
Right. Fair enough.
Yeah. What I was getting at with the clays question is that high temperature materials are a huge weakness of low-cost 3D printing right now.
Oh, yes.
So it would be, I mean, even just stuff that you can get away with putting in the oven would be an awesome trick, but I mean, it's all the nutty people doing DIY foundries that would love to be able to print stuff as well.
Right, so you're talking about...
You'd have to be careful about voids with that, because it's the whole thermal expansion and exploding pottery problem.
Right.
But,
yeah. So you're talking about printing like really hot materials, like a actual liquid metal, or are you talking about something that...
Printing room temperature clays and stuff so that they can use their printed parts in their foundries and other ridiculous things.
Oh, right, yeah, and you're right. A lot of that's going to be very material specific, and it's going to take some optimization. Somebody who knows that this is the way the material has to be formulated for that particular application. Yep. And then, so this is one of the problems I encountered as well, kind of in the vein of my PhD research, is people were interested in a particular type of material, but then it wasn't very printable. So then to make it printable, you had to change your material, but then now it's no longer quite the same material, and it may not have the properties that you really wanted in the beginning, and so it becomes kind of a cat and mouse game. And that's got me off of inkjet printing and into extrusion printing, because the material tolerances were a bit more flexible for extrusion. But nevertheless, there are still some materials that you pretty much need a beefier system to really push through, for extrusion printing. So we're trying to make something that's enough middle of the road that it can be widely used, and then we'll see where the broader interest lies. If people are using it just for cake icing, okay, then that tells us, all right, let's not make this super high power one, right? But if people are using it for types of materials, or we get enough suggestions that this particular material that they want to print and it's going to take a little bit more power, there's potential that we could develop something to work with that.
Mm-hmm. And I mean, I had assumed when you first brought this up that it was going to be a little servo-powered device just to save on cost of parts, but the nice advantage of using a stepper is that you can just gear that thing down and it doesn't really cost you anything, because it's continuously rotating. There's no harm in.
Yep. Yeah. And as far as like some of the values of this system will put out is roughly about 100 psi on the syringe would be the maximum. So that's pretty decent, and where we gauge that was kind of our own personal experience. So during my PhD research, when I was using air pressure, I found most materials that I really was interested in printing, I was able to print right around 89 psi. A couple of times I had to push it up to 100, and this was on shared laboratory air. So every time somebody else would use the air, pressure would drop. So it was fun printing sometimes, but typically around that range, it works very well for me. So and that's kind of what we've with the materials we've tested, they all fall within that same kind of range. And but anything that needs more power, not only will it take a more powerful motor, you also want to have a syringe and components that can withstand the pressure as well. So it may be a bit more of a customized system to put out more power.
That was going to be my next question, was what's limiting that 100 psi, motor strength or the
it's going to be more the syringe. The syringe itself actually acts a little bit like a physical fuse. So it's a polypropylene syringe, and I've actually put it under enough pressure that the syringe itself has ballooned. You know, I've had the syringe go from these narrow walls to like this because of the pressure inside, and you know, yeah, as soon as I saw that, I was like, oh, I better back off here. So. But fortunately, with it being polypropylene, it gives you the chance to actually do that before it just goes, you know, and messes up everything. So, yeah.
Yeah, consider putting it in a metal tube, basically just using your polypropylene as a sterile liner.
That is possible, yeah. And then, but what happens when you do things like that, though, is your weak point transfers into another weak point.
Of course.
And so, yeah, you're playing cat and mouse, hunting down the weak points.
Cool stuff.
Awesome stuff. What other questions you guys have?
Anyone else?
So Nick, you seem to be pretty excited about the product there.
Yeah, there's a lot of fun stuff to do with it.
Nick's been doing a lot of our research with different materials lately over his summer this year.
Okay.
He's been playing around with like dragon skin and a few other different types of silicones that are pretty useful for making the joints and possibly for making the grips on the fingers.
Yep.
And I have all sorts of schemes I want to play this into. Vibration isolation on my quadcopters is the other big one.
Oh yeah, that's pretty cool. Yeah. I had a good buddy of mine who has gone into jewelry sales, and he mentioned one thing: heirloom watches. You know, old watches that are kind of cool that you might find in an antique store that are kind of $50 or something like that. Oftentimes they're still nice watches, but they're not really used because the gaskets are rubber and they've broken apart and worn away, and nobody makes those gaskets anymore. Something else that actually can be done with our device is, those particular gaskets could be made, but then also custom gaskets for, say, a little electronic project box or something, very easily made.
Watch gaskets are probably tiny, but yeah, for all sorts of other stuff where you don't want water going places, certainly.
Yeah. And the tininess also, a lot of it factors into how you design it, because there might be some ways to design around, I think that's kind of what we've seen is a little bit is with paste, you still have to be a bit clever with your design sometimes to really pull off, something cool.
Well, that's any manufacturing technology.
Hi, sorry, I've been writing this whole time, but I got one of the batch 3s, and I'd be happy to test out materials for both the group and you guys. So.
Yeah, you already have one.
Very cool.
I'm excited to play around with this for sure.
Very cool.
Hey, can you tell us a little bit about the kind of designs that print well with these sort of materials? Because I have to imagine that support angles and overhangs and that kind of stuff all play by really different rules.
Yeah.
Yeah, exactly. So we haven't tried things, say, like printing a Yoda head in silicone, and I'm not very sure how easy that would be because the support you need for the ears and everything. So we most of the designs that we have printed, they actually they have a full base that then just gets a little bit narrower as you go up. So like the little stair step piece is a good example of that. It held its shape very well through the whole printing, but nevertheless it had a large base and smaller on top. The iPhone case was probably one that where we pushed the limits a little bit more because you have these narrow walls that have to go up about 1 centimeter, and we just you decide, okay, let's try it, and we're actually reasonably impressed. It turns out pretty nicely. The problem on the iPhone case ends up being a little bit with the slicer algorithm. So like for the little hole for the camera, there's a few little gaps, and it's not because of the printing, because it's filled in very nicely everywhere else. It's just because for some reason with the slicing, it just does some weird stuff around that point.
Yeah.
And then there was one little corner of this iPhone case that was just a little tiny narrow wall all by itself, no other surrounding walls to support it. And first time we tried that with clear silicone, the silicone step kept sticking to the layers and getting dragged as it kept building it up. So that one didn't turn out well, but then when we tried that same iPhone case with white silicone, that little corner wall all by itself printed actually very nicely. So so yeah, you do have to use a little bit of common sense with silicone or with paste materials in general, and we haven't really pushed the limits to like show something that here's some supports that we could cut away afterwards and this just printed awesome. And a lot of the limitation is really the fact that paste material doesn't cure instantly like the plastic filament does. So trying to use the paste as a support, yeah, it's going to be tricky depending on how you do it. And but then it may be possible to use something like cake icing as a support for something, some other kind of paste like a silicone, and then just wash it away afterwards. So a lot of those ideas we really haven't pushed the limits on.
Mm-hmm.
Yeah, I like the idea of the. Sorry, echo. I like the idea of using something soft as a support material that can be washed away. I like that idea a lot. You can see a lot of applications for that. Maybe not. We've done a lot to avoid needing supports in a lot of our hand designs, but there are still places that, like inside the palms, there'll be space that they need to put supports in to fill the space, and if we could fill it with something else that wouldn't create little uneven surfaces inside the hand, that could be nice.
Yeah. And another thing too, the types of tips that we have access to, and we're not going to be selling all of our tips to just broadly to users, because we're going to try to focus mostly on carrying inventory of the most widely used ones. But they actually have stainless steel tips that have something like a little 2-inch long tip, which can be submerged or dropped into a recess and then printed there. And the cool thing with that, in addition to dropping into a recess, is you can also submerge it in another liquid and then do 3D printing liquid inside a liquid, basically. I actually did some stuff like that for my PhD and encapsulated some conducting polymers, and that was pretty cool. So that is something else that, depending on the type of task you're trying to do, might be useful. And if that ends up being the case, let us know, and we can try to supply you guys with tips.
Okay. Yeah, that might be of use.
Also,
go ahead.
Okay, I was going to just add another comment in on the design side on how paste printing hopefully will get people thinking a little bit differently about how they design a print. If you think of the typical bracelet that you print with PLA, it's this little spiral that goes around in a circle, and then you just build up, and you keep repeating these circles up to get because PLA itself is not flexible, so you have to design an accordion structure to make it flexible to use it as a bracelet. Whereas with something like a silicone, you could actually print a complete flat rectangle with a little hole on one end and a ball on the other end, and then wrap that around as a bracelet in that form. So that's just another way to think about 3D printing with paste materials. Is they always have to follow the designs that are out there on Thingiverse, and everybody who's designed things for Thingiverse, a lot of times they've still been thinking in terms of plastic filament. And so hopefully with the paste with the Discov3ry extruder, it'll get people thinking a little bit differently about the designs. There'll be some designs that are better for paste, some designs that are better for plastic, and then you can pick and choose between the two.
I meant to ask, what's the approximate horizontal footprint of your part, of your the part that goes on the gantry? What's its X and Y dimensions?
Oh, okay. Well, it really is just a tube and a tip. So the X and Y, how much space it takes up, kind of depends on how you want to add it onto your printer. If you use something like a zip tie and just zip it to the edge of the existing chassis, it takes up virtually no space at all. If you use something, like if you, what we did for our Felix 3.0 is we just got a plastic block and drilled a hole in it and had a little thin piece of plastic that we bolted the block to, and so the tubing then goes through this block, and so there's a little bit more space, but it only adds about an extra, I'm looking at it right now, about 1.5 inches at the most to the width of the carriage, so it's really not that bad.
Yeah, so the tube's like what?
And there would be other ways to optimize. Yeah, so the tip is 1/8 of an inch internal diameter and roughly little less than 1/4 inch for the outer diameter, depending on what type of tubing and so on.
Okay. Yeah. Cool. So probably would be possible to cram like 4 of them into your standard carriage if you were.
You could, and then. And then the trick would be if you wanted to have a retraction, for example, so that way if you're printing one material, it doesn't the tip doesn't drag into your second material when you're trying to print that. So if you wanted to cram like 4 of these tips in one place, you just want to make sure that you set it all up properly so you get the kind of print you're hoping for.
Yeah. Cool stuff.
But yeah, I mean, it would be very easy to say even design something that you print in PLA or ABS that becomes the custom holder for these tubes and so on. And so we decided to just sort of leave that part of it open-ended because everybody kind of has their own specific ideas of how they want to integrate it with their printers. So rather than us telling everybody, here's how you do it, we'll give them ideas and then everybody gets to satisfy it their own way.
Cool.
So Trouble, you had some other questions?
I didn't. I was just trying to encourage the other people who have been muted most of the conversation, if they have any questions, to go ahead and ask them.
By all means.
I have no questions as of yet. I'm sure I'll have a lot of questions once I start.
Exactly. And we do intend to stay fully engaged with the community. This really is only the beginning, and so we're hoping we kind of spur a movement here of getting people to print with paste, and we definitely want to do everything we can to support that movement. So any questions you guys think of later on, by all means, get involved with our forum, and we'll make it a point to be as responsive as we can be to keep the conversations going.
Did you post a link to your forum, either in the sidebar or in the notes?
Absolutely.
Or both?
There it is.
Awesome, thanks. Oh, and by the way, Dante, thanks for taking notes for me. I tend to not do so well when I'm taking them because I have difficulty typing while listening.
No problem.
I definitely appreciate that. Did you have any questions, Tim?
No, I think I'm good. Sorry, thanks. It's my first time on one of these Hangouts with this team. So.
So actually, I don't know if everybody kind of understands how your device connects to a printer and works with the printer.
Okay.
Do you want to kind of talk through that a little bit?
Yeah, sure. So as mentioned before, it's driven by a stepper motor. So it's got the standard 4 wires coming out of it. And so where you have an open slot on your ramps board, you plug in those 4 wires to the stepper driver on your ramps board. That connects the motor then, so now that's fully controlled. And the unit itself is designed to either, it will be designed to either stand freestanding vertically next to your printer, or if you choose to do so, you could mount it to the side of your printer frame. And then there'll be a tube coming out of the top of our device, and at the end of that tube is where we have the tip that connects. And the tube and the tip and the connectors and the syringes, those are all consumable parts. So, you know, with something like cake icing, you could wash and reuse that, all those parts. You know, have to save a little bit if you wanted to. With something like the silicone, it's going to be a bit tedious to try to clean all that, so the intention there is probably to make those more disposable in the case of something like a silicone or polyurethane or whatever. So, and also when these components are subjected to pressure, that also limits how many times you can reuse it, because they just start to wear down with the application of the pressure. So at the end of the tubing is the tip, and you apply that, you connect that somehow to your carriage that has your existing filament nozzle on it, in whatever way makes sense to you, and that essentially is it for the hardware connection. And then on the software side of things, you basically you can update the firmware to disable the heat safeguard, so that way your system is not waiting for the nozzle to heat up, because we don't have the heating capability on our nozzle at this point. Or on a per session basis, you can just submit some G-code to your system, and then that will disable the fail-safe for that session until you reboot everything. So that's, for the most part, it. Is there anything else in particular in between all that that somebody has a question about?
I don't think so. So if you just connected, it looks like an extruder. You just with the right steps per millimeter, and off you go.
Pretty much, yeah. The printer itself doesn't know that it's working with a different extruder. The behavior in those terms is very much like a filament extruder.
How about the printers that don't have spare extruder controllers?
Yeah, if it's a single,
like most of the dual, like a Replicator 2X, for example, 2 extruders, 2 controllers.
Yep.
Unless you're populating things on the board.
Right. Right. So in that case, you have a couple of options. If you wanted to get creative, you could have a connector. You know, you could have some wires sticking out of your ramps board with a connector and a toggle switch between 2 different extruders, and you toggle it based on which extruder you want to power up. And then that way you don't have to connect and disconnect and reconnect and all that. The other option is just doing the full disconnect and reconnect for a printer that is fully populated with extruders.
You can also just set up an extra Palula driver just next to the main board. I mean, it's only one actual data line, or that's not true. It's 2 data lines to control these things. So you could, I mean, you can do all of your power and all that stuff off of regular stuff, and then just use 2 little I/O pins that almost every board has to spare for Steffender.
Yeah, so we've intended the integration to be as easy as possible. We didn't add any lock-ins or any other goofy stuff to prevent people from trying to integrate our product.
I guess how flexible is the tube that you're using to connect? Actually.
Yeah, it is quite flexible. So we started off using Tygon tubing that we sourced from Cole Palmer. So that is based Teflon lined. And then lately we've been experimenting with much less expensive vinyl tubing, like what you would use for if you were making your own beer at home and brewing that. So still, food safe and everything, but a fraction of the price compared to something like the Tygon tubing. So in the laboratory, if you're doing something that's highly sensitive to food safety and you just want to have that absolute, then something like the Tygon tubing might be recommended. It's just it's about $100+ for 50 feet of it or something like that. Whereas the vinyl tubing is much less. So so we're thinking what we'll be providing is the vinyl tubing as the starter kit and the refill kits to customers because we can keep the price down, and therefore, customers come to us as a one-stop shop, and they pay a lower price as well. So the tubing is very flexible. It's just normal, vinyl type of tubing.
I was wondering about putting a ball in the tube to separate, say, water or whatever material you wanted to push from a material that you actually wanted to extrude, if it was particularly expensive or you just didn't want to use that much of it for whatever reason.
Oh, okay. So, well, there could be a couple of ways to do that. If you wanted to, it would be possible to use our system, and then instead of putting the tip at the very end, you have the hose connecting to a cap on a small syringe that's, say, 5 cc or 10 cc or whatever, to work with a precious amount of material. And then you use our device to basically either plunge air or put water in the syringe in our device or some other liquid that's easy to compress, and then that in turn compresses a smaller syringe at the end of the system instead of the tip like what we provide, that is mounted kind of in a custom way on a small printer. So you sort of have a daisy chain going on there, but it can still be controlled with our device. So that's a way to think about engineering that.
Yeah, that's essentially what I was talking about.
Yeah, so.
Good stuff.
So it sounds like we're either repeating questions or starting to run out of questions. It's a good time to start wrapping up. If there's anything you guys wanted to say as a final note on the message, just go ahead. Sorry about the echo. My computer tends to do that when I've got the microphone not muted.
No worries. So, well, as I iterated in the beginning, structured printing is very much behind what you guys are doing for e-NABLE. So we will donate a Discov3ry extruder to the group to help with the efforts. And so once we have our units in reliable production, that'll be about the timing that we send a unit to you guys. So Trouble, I'll just coordinate it with you, I guess, as to where to send it to, and then we'll continue to engage you guys and try to help you out wherever we can. As a small company, it's kind of limited in how much we can help now, but nevertheless, we're very enthusiastic about what we're doing. So we'll definitely do everything we can, and then as we grow, certainly we'll be able to help a little bit more. And we could also do, once a month or whatever frequency hangouts with you guys to, if you have any further questions, they just kind of collect over time or something like that. So that's certainly an option. And
I do host bi-weekly R&D hangouts, so I'll make sure to include you guys in the invite list if you guys have a Monday off and it's and the meeting's planned. You're welcome to join.
Okay,
yeah,
certainly, great.
That would be good. We might just drop in now and then, and more instead of taking all of your hangout to see what you guys are up to, and maybe offer ideas for how we can help.
Okay.
And I guess I'll take this opportunity to say thanks to Laird for helping to put this together, and for I guess sticking around on our forum even after we inadvertently ignored him for 20 days when he mentioned that.
I am nothing if not persistent in promoting e-NABLE, so I'm glad we reconnected.
Yeah,
very exciting.
Absolutely. Thank you.
All right, well, I'm going to go ahead and stop the broadcast then. Thanks for joining us, and this has been informative.
All right, thank you very much, guys.